we'll be talking about planets. We'll be talking about how big planets are, how far away they are, how many moons they have, and also if there's planets around other stars. We've got a number of scale models as well, so we'll be able to see how some of the other planets compare in size to the Earth, the same scale.
Just put the lights off there.
No, that's all right, because I need some light so that I can show my things here. Also video here, so hopefully I'll get that up on YouTube sometime. If you Google something like BDAS astronomy, you might see the talk again if you fall asleep. So if we start with the Earth, because we all know the Earth, we all live on the Earth. It's about 12,700 kilometres across. Now if we reduce that by about 30 million times, we get a ball this size. So all the scale models I'll show you are at the same scale as that, 30 million to 1. At that size, if we reduce the moon now, that's how big the moon is compared to the Earth. Now there's a couple of good ways to judge how big the moon is compared to the Earth. One is that 4 moons basically fit more or less across the diameter, but also the Earth, the moon is about the same size as Australia. So when you see a full moon and you look up at it, from one side of that full moon to the other is about the same distance as from Sydney to Perth. And yet you can blot it out with one little finger from that distance. So at that scale, that's the size of the moon. Anyone want to have a guess where the moon would be relative to the Earth? So like, is the moon here? Is it here? Is it out the door? Anyone want to have a guess? Sorry, how far?
About 600 metres away.
Oh, at the back there, you had your hand up?
Yeah, it's not better, right?
About where you are. Now if we can have a volunteer, I won't expect any of the adults to get up, but we can measure out. Any of the kids want to get up? Come on, you've got a big smile on your face. Yeah, you just grab that and start walking over towards the door. Walk up between all the chairs. Keep going. Keep going. That's it. So that's about at a scale of 30 million to 1. That's how far away the moon is. So you can see why it took them. Okay, you come back in now. You can see why it took them about 3 days to get there in the Apollo craft. I'll let my assistant wind it back up. Right, so at that scale, the moon is about 12 metres away. Now all of the planets revolve around the sun. And at this same size, how big would the sun be? Anyone want to guess? Would it fit in this room?
About 15 metres in diameter. Over 15
Some of the guys are working it out in their heads, which is sort of cheating. Yeah, you're good, because you've got a different scale to work it out from now. So you have an idea. Right, we won't be measuring it, and I don't bring my scale model sun with me, because yeah, it would be 45 metres in diameter. So you see, if I was standing here, here's my little Earth ball, and there's little me. Here's the distance from the Earth to the moon. So the sun is almost 4 times bigger than the Earth to the moon in size. So we know how big it is. How far away do you think it would be? We can see the moon is over at the door. How far away do you think it is? Say in kilometres or to somewhere.
Well, on the chart, but I haven't heard, it's like 12 million .7 kilometers away.
So about
on the scale, but yeah, it's a long way away. That's why we won't actually measure it tonight.
Bendigo Creek, maybe? Bendigo Creek.
Well, the locals might have an idea of how far that is, but I don't. But, no, we won't be measuring it in actual fact tonight, because we don't have enough time to roll out this ball of string. And then roll it up again neatly. Because it would be almost 5 kilometres away at this scale. Or about 12,000 Earth diameters. So what are the names of the planets? And we're only going to take planets, so we won't take anything that's not a planet.
What do you describe a planet? What rules are you using?
The one that fits the IAU.
Well, that rules are the current
The
document.
new rules.
Yeah, the new rules. The current planets. The one that excludes the one that everyone will probably want to put in and they don't. Okay?
Mercury,
Yes.
Venus,
Yes.
Mars,
Yes.
Earth,
Yes.
Jupiter,
Yes.
Saturn,
Yes.
Uranus,
Yes.
Neptune.
Yes. And you stopped at the right point. Yes, that's all of them. I was wondering whether you'd actually include the Earth, and you did. Because a lot of people will name all the other ones and they leave the Earth out, because, I suppose because you're already here, you know that. So yeah, we've got 8 planets and 5 dwarf planets at the moment. You'll see later when we talk about dwarf planets, that figure could possibly be revised in the future, upwards. And each of the planets orbit around the Sun, and as they get further and further out, of course, it gets colder and colder, and they take longer and longer to go around. So if we start with our first planet, which is Mercury. Now Mercury is around about half the distance of what the Earth is. And in scale, that's how big Mercury is compared to the Earth. You see, it's not a lot bigger than the Moon, but it's quite a lot smaller than the Earth. In this scale, it would be 1.8 kilometres away from the Sun. We're about 5 kilometres at this scale. Now in the last 6 months or so, a new probe, a messenger probe, has just entered orbit around Mercury. And it's the first mission that's gone around Mercury since the 1960s, when Mariner 10 flew past, took pictures like crazy, came back around the Sun, came back again, took more pictures. Unfortunately, the pictures were of exactly the same side it took when it went past the first time, so they've got 2 sets of photos of the same side. Messenger is actually orbiting Mercury and it will be there for quite a while, and it's taking lots of very high resolution photos. And you can see craters. In fact, it looks an awful lot like the Moon. If I didn't tell you this was a picture of Mercury, most people would say that it's a picture of the Moon, because it's just covered in craters, very, very similar. When you look at it at closer detail, of course, it's very different to the Moon, but superficially it looks very much like our Moon does. Next planet now is Venus. Venus used to be called our twin planet or sister planet because it was thought that it might be similar. In actual fact, we know there's nothing like it. You can see it's almost the same size, it's only slightly smaller. And when you look at Venus through a telescope, it actually looks pretty much like this, a big white ball. You don't see any particular features or anything because it's totally covered in cloud, very, very thick cloud. And that reflects so much light back, and that's why it's so bright. So when you see the sun go down at the moment, when the clouds are not there, you'll see this very bright star over the next few months, and that will slowly climb its way up. And that's the planet Venus. If we could take all the atmosphere away, and we could actually look at the surface, they've been able to map the surface by using radar. Radar goes through the cloud as if it's not there. So we can actually map the surface. And they know that the temperature there is about 500 degrees C, hot enough to melt lead. There's about 1,000 craters on the surface. And interesting, it rains sulfuric acid, but because it's so hot, the rain doesn't actually make it to the surface. It evaporates before it reaches the surface, which is what meteorologists call virga. So sometimes you might see the rain, particularly in the summer, you look out in the distance, you see this rain coming down, and then the rain just stops. That's because it's evaporated before it actually hits the ground, and that's what they call virga. There's 167 volcanoes on the surface that are bigger than 100 kilometres across. So massive. Now back in the early 1980s, the Russians landed a number of probes. They had a lot of failures because they didn't realise that the pressure was so great. And their probes were coming in through the atmosphere and they actually got squished by the aluminium can before they even got within 10 or 20 kilometres of the surface. And the first one that actually made it to the surface was Venera 13. They survived for nearly 2 hours in 500 degrees C. So that's like you imagine putting a mobile phone or a television or something inside your oven and double the temperature and see how long it lasts. So their equipment was able to last about 2 hours. And it returned pictures of the surface. This is the surface of Venus. You can see it's just covered in all this grey volcanic rock. This little thing down here is a lens cover. As the probe was falling down through the atmosphere, to protect the optics, it had this metal lens cover over the front. When it landed on the surface, it popped the lens cover off so it could take these pictures. So this is the lens cover sitting on the ground of Venus. This little mechanism here is a spring-loaded thing. So it bends here like the elbow, and when it landed, it fired this spring arm out and has what they call a penetrometer on the end. And that would impact onto the ground and they could measure how hard the rocks were. So it would land, pop off the lens cover, go bang, measure how hard the rocks were and bring in bits of the atmosphere and measure temperatures and pressures and all that sort of stuff. The next one, Venera 14, similar. As you can see, the ground is very similar. It's a little bit flatter. Unfortunately, when the lens cover came off, it landed here. And when they fired the penetrometer, it landed exactly on the lens cover. So they knew exactly how hard the lens cover was. Which of course they already knew. But it was very unfortunate that it just happened to line up exactly. So the poor little thing is still sitting on the surface of Venus, waiting for someone to pull the lens cover away so it can measure how hard the rocks are. Except it's probably all burned to a crisp by now, because it's been there since 1982 or so. As I said, Venus, if you look out towards where the sun sets, right, so in the west, whichever way that is here, I don't know, there, and you'll see this bright star when it's clear, and up until around about Christmas, it'll get quite high. It'll set maybe a couple of hours after sunset. By about Christmas, it'll get to its peak, and then it'll slowly drop down again, and then you won't see it again in the evening until much, much later in the year.